All right. On worksheet 14.1 from the other day, as we begin looking at tangent today, we should realize tangent is nothing like sine and cosine. It's a completely its own being. All right? The first thing you should have realized when you were filling in that worksheet 14.1 and looking at tangent is there were some angles that did not work. There were some situations that were undefined. Now, on a graph of tangent, when there's a situation that is undefined, that creates a what? Asymptote, vertical asymptotes, vertical lines that my graph gets closer and closer and closer to but never touches. It tries very hard, but it never gets there. It gets closer and closer and closer, but it never quite touches that vertical asymptote. So that means that a cycle of my graph for tangent occurs in between those vertical asymptotes. So I have a cycle for tangent here, I have a cycle for tangent here, I have a cycle for tangent here, and I could repeat and repeat and repeat. Now, one comment. As we investigated sine and cosine over the past 2 days, we should realize that for sine, all right. Here we go. Continuing on with our notes. All right, the last couple of days we have sine and cosine. So y is equal to a sine of bx, and we've been looking at y is equal to a cosine of bx, all right? What we should realize, for sine it always starts where? 0, 0. Okay, so sine starts here, it goes to the top, back to the middle, down to the bottom, continues forever and ever and ever and ever. Cosine starts where? At the top, down to the x-axis, down to the bottom, back to the x-axis, up to the top for one full cycle, and it continues on forever and ever and ever and ever. Now, the reason I quick drew these up is I want you to realize that for sine and for cosine, we start at the y-axis, and our first cycle is to the right of that y-axis. Does that make sense? We start at the y-axis, and our first cycle for sine and for cosine is to the right of that y-axis. But what do you notice about tangent? Okay, it's in the middle. Notice that my first cycle for tangent, half of it is to the right of the y-axis, half of it is to the left of the y-axis. So that is one fundamental difference with tangent. One fundamental difference with tangent. Now, in addition, you will notice that tangent always goes through what point? 0, 0. So that is going to be a clue for us. All right, so let's take this and look at what the characteristics will be if we change this into y is equal to a tangent of bx. So y is equal to a tangent of bx. All right, now that a number with sine and cosine, what did that a remind me of? Amplitude, okay? And what is that amplitude? I mean, not like number, but what is it? Okay, it is going to be, in our cases, the past couple of days, it has been positive. The absolute value of a, okay? Now, what by definition is amplitude? What does it look like on my graph? Okay, it's the distance from the middle of that graph to the top of the sine, from the middle of the graph to the bottom of my cosine. Now, think about how that relates to tangent. What about our amplitude? You can't have one. We can't have one because tangent doesn't have a maximum or a minimum. Tangent keeps going forever and it continues forever. I can't find half of the difference between the maximum and the minimum because I don't have a maximum or minimum for tangent. They go infinitely to positive infinity and infinitely to negative infinity. Does that make sense? So there is no amplitude with tangent. However, the a value will help me for something very important in a bit. Now, what does the b help me with? The B helps me find the length, the horizontal length of the cycle. The B helps me find the period. Now for sine, it's 2 pi over absolute value of B. Okay? For tangent, that is not the case. For tangent, it is actually pi divided by absolute value of B. Pi divided by absolute value of B. But I've got to make one comment. Now, that means that the distance on my x-axis from here to here is actually pi divided by absolute value of B. So, this vertical asymptote will be at what of that? If this is pi over absolute value of B, how much is on this side? Half. And how much is on this side? Half, okay? So that means that my vertical asymptotes are at pi over 2 absolute value of B, a half of pi over absolute value of B. All right, so what that means, what I'm looking at then, my vertical asymptote here, if my vertical asymptotes are actually at odd multiples because they continue to repeat and repeat and repeat and repeat. But if my period is pi over absolute value of B, that means that my vertical asymptotes are at x is equal to a half of the period. I'm going to say P is the period. Because I go to the right a half of the period to get to that vertical asymptote, and I go to the left a half of the period to get to that vertical asymptote. So I'm going to say it's actually x is equal to a half of P and x is equal to negative a half of the period. So here I'm at x is equal to a half of P. Here I'm at x is equal to negative 1/2 of the period. All right, couple of other comments. So first of all, it always goes through the point 0, 0. All right, then here's an interesting thing. So when it says to graph your 5 key values, 5 key values do not mean points when we're dealing with tangent. It means 5 key x values. What happens at 5 key places for x? Well, first of all, 2 key things are my vertical asymptotes. So x is equal to a half of the period and x is equal to negative a half of the period. Then there are going to be 3 points that I'm going to graph. Now we already commented that one of those points is going to be 0, 0. Okay? Very interesting. If this is a half of P, what will this be? A fourth of P. And this will be negative a fourth of P. Okay, so what is interesting at that spot, if I take a quarter of my period, I will always be up at the A value. So if I take a quarter of the period, I will always be up at that value of A. If I take negative a quarter of the period, I will always be down a distance of A. So I'm going to graph my 2 asymptotes, I'm going to graph the 3 points in between, and I'm going to make that 1 cycle of tangent, and everybody's going to be happy. Are we okay with that? All right, let's try one with numbers. Tangent typically is a case where people feel a whole lot better when they start dealing with numbers. Okay, so we're going to graph y is equal to half tangent of a third x. Okay, as I talked about yesterday with sine and cosine, I strongly recommend above it you write y is equal to a tangent of bx. Because I realize very quick, what number am I going to use for a? 1/2. And what number am I going to use for b? 1/3. Okay, now a reminds me of, what word does a remind you of? Amplitude. For tangent, what is my amplitude? There is none. So for amplitude, I'm going to write none. There is no max or no min. So I cannot have an amplitude. However, on my graph, there is something very important that happens at that a value. So if I go up 1/2, something important is going to happen. And if I go down 1/2, something is going to happen that is very important at that spot. All right. Now, my b value. What does the b value help me with? The period. Okay, and how do I find the period for tangent? Pi over the absolute value of b. All right, so in this case, it's pi over the absolute value of 1/3. So how do I take pi and divide by 1/3? Multiply by the reciprocal. So pi times 3 over 1 is 3 pi. All right, now for tangent, does that 3 pi go on my graph? No. No. For tangent, your period does not get drawn on the graph, but the period helps me to find the vertical asymptotes. Absolutely, the period helps me to find those vertical asymptotes because those vertical asymptotes are at 1/2 of the period. So if I take 1/2 of 3 pi, I get 3 pi over 2. So I know that my vertical asymptotes will be at x is equal to positive 3 pi over 2 and x is equal to negative 3 pi over 2. Is everybody okay with that? So I randomly pick a distance of 3 pi over 2. I go to the right 3 pi over 2 and I make a vertical dash line to represent that asymptote, that line that my graph approaches but never touches. X is equal to 3 pi over 2. And I go to the left 3 pi over 2, the same distance, to negative 3 pi over 2. I make that vertical line that my graph approaches but never touches at x is equal to negative, bless you, 3 pi over 2. All right. Now, 5 key points. Really, with tangent, there are only 3 key points. There are only 3 key points for tangent. We have 2 asymptotes and 3 key points. Now, where is the first point that I'm going to put on my graph? 0, 0. Okay, so I know that I'm going to plot it at 0, 0. And then I'm looking for my other 2 points. Now, the other 2 points come at 1/4 of p. So if I take 1/4 of my period of 3 pi, where am I at? 3 pi over 4. Okay, so halfway between 0 and 3 pi over 2 is going to be 3 pi over 4. Now, when I'm at 3 pi over 4, what will my y value be? I will be up to that a, which means I will be up to 1/2. So the next point is going to be 3 pi over 4, comma 1/2. All right, my second point is going to be at negative 1/4 the period. So negative 1/4 of 3 pi is negative 3 pi over 4. So halfway between negative 3 pi over 2 and 0 is going to be negative 3 pi over 4. And at negative 3 pi over 4, where am I on my graph? I'm at negative 1/2. So my point there is negative 3 pi over 4, negative 1/2. Okay, now, I know that this kind of looks like a line, but it's not a line. It's like a snake curve built inside of those vertical asymptotes. So from 0, 0, it goes up through this point, approaching that vertical asymptote, and from 0, 0, it curves down, approaching that vertical asymptote. All right, now, what about my domain? Can I have everything I want? No. What numbers can't I have? I can't have 3 pi over 2, I can't have negative 3 pi over 2, and actually I can't have increments of that. So the way that we're going to write that is we're going to say x does not equal odd multiples of 3 pi over 2. X does not equal odd multiples of 3 pi over 2. What about my range? What about my y values? All reals. I got anything I want for y. All right, should we try one more? All right, let's take a look at one more. All right, so y is equal to 3 tangent of pi over 2x. So first things first, write down y is equal to a tangent of bx. All right, what number do I have for a? 3. What number for b? Pi over 2. All right, so a reminds me of what, Levi? Okay, something important happens at a. If I go up 3, something important will happen. And if I go down 3, something important will happen. Now, what else does a make you think of? Amplitude. So what about amplitude for tangent? Okay, what is the amplitude for tangent? There is none. Okay, so don't forget, they're going to ask you for amplitude. You've got to write none because there is no max or min. Don't forget to write none. Okay, what does b help me to find? Leslie, what does b help me to find? All right, and how do I calculate the period for tangent? Pi over the absolute value of b. So if I take pi and I divide by the absolute value of pi over 2. All right, Alex V, what am I going to do for that? Pi over the absolute value of pi over 2.
Take the reciprocal of the bottom.
Okay, so pi multiplied by 2 over pi, which gives me, yep, pi's are going to cancel and I get 2. All right, so my period of this graph is 2. All right, Brendan, do I put that on my graph anywhere? Nope. What do I use that for? All right, and how do I find the vertical asymptotes for tangent? You bet. It's always 1/2 of the period, so 1/2 of 2 is?
1.
Perfect. Which means that if I go to the right one, there's going to be a vertical line that my graph approaches and never touches that has a name of x equals 1 for my asymptote. And if I go to the left one, there is a vertical line that my graph approaches but never touches with the equation x equals -1. Remember, vertical line, you've got to be thinking VUX. That equation has got to be written x equals the number. Not just 1 and -1. X equals 1. X equals -1. All right, now where do I go next? Got to find some points. And how many points am I looking for?
3.
Okay, technically there are 3, not 5, like sine and cosine. There are 3. What is the first one? 0, 0 is a beautiful one. So I'm going to plot 0, 0. Okay, then I need to find some other points. All right, Katie, what do I do to find the other 2 points? A fourth of p, which is?
1/2.
Good, a fourth of 2 is 1/2. So when my x is 1/2, so between 0 and 1 I'm at 1/2, what happens for my y value? It's up at 3. So my point is going to be at 1/2, comma 3. All right, what about my other point, Brooke? All right, you bet. -1/4 of p, so -1/4 of 2 is just -1/2. So between 0 and -1, I'm at -1/2, and what is my y value at that point? -3. So my third point is at -1/2, -3. So this asymptote, this part of the graph goes up and to the right towards that vertical asymptote, and then the other part of this graph curves down towards that vertical asymptote. All right, what about my domain? Who's got a thought on domain? Beautiful. X does not equal odd multiples of where my vertical asymptote is, which is 1. How about range, folks? My y values can be anything they want, so it's all reals. Yes, sir?
What do you mean by odd multiples?
Odd multiples means if I take odd multiples means if I multiply by odd numbers, so 1, 3, 5, 7. So if I take 1 times 1, it'll be at 1. 1 times 3, the next one will be at 3. Times 5, it'll be at 5. Or times negative 1, times negative 3, times negative 5. That is where my next little brick walls will be. Every increment that's an odd multiple of 1 will have a vertical asymptote. Great question. Other questions? Yes? For tangent, range will always be all reals. It always goes all the way to positive infinity and keeps going all the way to negative infinity. Absolutely. Anything else? All right.